Hello everyone, welcome back to MATLAB programming class. I'm Hossein Tutunchi and today we're going to continue our discussion on derivatives. One of the most important areas in calculus is partial derivatives. And as you know, there are numerous applications where we're required to find the value of a function at some specific points and then continue from that point on. As you know from calculus, partial derivatives make sense when we're dealing with more than one variable. We can define variables like sims, x, and y. And then now I'm going to create a function called f1 equals. As before, I use inline. And let's create x, something easy to work. X squared plus 2, let's go y cubed, just to start. And then what are the variables are x and y. We can create a function which has more than one variable. Now we're dealing with x and y. As we learned before, we can calculate the derivative as passing diff. And what's the function is going to be? It's going to be f1 of x and y. Because now we're dealing with more than one variable. Without it, you get an error. At this moment, we're required to tell MATLAB which variable we're interested in, so MATLAB can take derivative according to that particular variable. As we know in partial derivatives, we're interested in one variable at a time. At this moment, let's go with x. I'm telling MATLAB to calculate the partial derivative of a function which has more than one variable, x and y, and now I'm particularly interested into x variable only. If I calculate this, MATLAB has no problem to take the derivative of the function, which was a complex one. The way that the MATLAB approached this problem was that because we told MATLAB that we're interested in x, therefore this part of the function which has y is going to be considered as a constant, and the derivative of a constant is going to be 0. Now let me try that again with a new function called d2, derivative of function f1, the second derivative, and here instead of x, I tell MATLAB to calculate it for the y variable. And if I do that, you see that MATLAB this time considered the first part of the function as a constant and took derivative of this part. Let's calculate another one. Let me clear the screen. With x and y already defined as symbolic variables, now let me create the second function as inline of x sine of y. I'm trying to calculate something more complex than before. Minus y multiplied by sqrt of x, 4. And what are the variables are x and y. So in this part, I defined a much more complex function, and then the x and y still are our variables. With that said, the f2 function was created. Now I am trying to calculate the derivative. I define d1 equal diff. What's the function? f2 of x and y. And at this point, I'm interested in x variable only. MATLAB has no problem deriving the complex operation for us. Now I pass the d1 function into MATLAB, and it has no problem making that more clear for me. At this point, let's go and calculate the function again. This time I changed the name to d2, and let's calculate it according to y. And if I do that, now let me make that more clear. And as you see, if you want to do it on paper, it's going to be very hard and time consuming. Let me clear the screen. As we discussed before, we have no problem calculating the function. This is the last one, the derivative that we found. But there is a problem. If you're interested to find the value of this function in some specific points, because now we do have a function called d2 and it has x and y. But if you want to find the value of this derivative at some specific x and y, we're not able to do that. So if I do this, d2 of, let's say, x and y, not x and y, 1 and 4, let's say, because I wanted to substitute the values. If I do that, MATLAB does not understand what we're doing, because the d2 function is not defined for MATLAB as a function. It is defined as an expression. So this one is merely an expression. And as we learned before, the way that we can do that is through a new function, which we can easily set up through inline. So I put inline diff of f2 x and y. I'm just setting up the whole thing again. And now I need to tell MATLAB what are the variables, and variables are x and y. So this way I define the differentiation of f2 of x. I think there is going to be another one, f2 of x, and this way MATLAB understands what's the function. By now the g2 function is not an expression. MATLAB understands it completely. To show you how does it work, let me pass some numbers. So now I put x value as 1 and y value as 2, and if I hit enter, MATLAB has no problem calculating the value of the derivative at that specific point. Let's go with g of -1 and 37. Sorry, g2. The name is g2. As you see, we could easily use what we learned before and expanded that into partial derivative thing. And don't forget to create multiple functions and play with them. And this is a very good way to learn MATLAB and be confident in each section. With that said, I see you in next video.